On this slide, we talk about radian measure. So before I start, I want to talk about positive and negative angles. So if you move in the anti-clock direction, you get a positive angle. If you move in the clockwise direction, you get a negative angle. So negative angle in the clockwise direction. So let me first draw a circle of radius 1. A circle of radius 1 will have circumference 2 pi r. Since the radius is 1, the circumference is 2 pi. And we interpreted that going around once a circle of radius 1 is equivalent to covering distance of 2 pi units. And it is from here that we get the radian measure. So for a circle of radius 1, the distance travelled on the circumference of the circle is same as the radian measure or the angle subtended by the circumference on the center. So this will be clear in a second. So again I will say that this is the angle subtended by the circumference, the small arrow around the center, and this angle is subtended by the one complete revolution on the circumference. So the angle subtended inside is called 2 pi radians. So the entire circumference of 2 pi units subtends an angle 2 pi around the center of the circle. So let me write this down. So for a circle of radius equals to 1, everything is very simple. Whatever arc length you have on the circle, the radian measure is the same as the arc length. So radian measure is the angle subtended by the arc on the center. So this 2 pi radians is equal to 2 pi units of length. Yeah, so there is this equivalence here. And basically that means that the entire circle subtends an angle of 2 pi radians. So this will be more clear now. So instead of taking the entire circle, what if I take like a small piece of the entire circle? Yeah, and this small piece measures 1. So if the small piece measures 1, then the angle it subtends, so this is the angle it subtends. So this angle it subtends is also 1 radian. So this is how the story of radian comes about. You draw a unit circle and you take any arc on the unit circle and it will subtend an angle at the center. And the angle at the center it subtends is same as the arc length. So for example, if you took arc length 1, it subtends angle 1. If you take arc length 2, it subtends angle of 2 radians. So you can go till 2 pi. So 2 pi is about 6.28 approximately. So if you take arc length 5, the angle it will subtend is 5 radians. Now we want to go from circle of radius 1 to any circle of radius r. And again, the entire circumference, that is 2 pi r, this will subtend an angle of 2 pi radians. So if you have 2 pi r length, it will subtend an angle of 2 pi radians. So let us see this. So if you go once around the circle, so you go once around, so this is 2 pi radians, and this entire 2 pi radians is subtended by the entire circumference. So the entire circumference of 2 pi r subtends an angle of 2 pi radians at the center of the circle. So what if arc length is just some arbitrary number r, but since, so what if arc length is number r, where r is the radius? So if r is the radius, then it will subtend an angle of 1 radian. So in the first case we saw 1 radian was subtended by arc length 1. Here we see r will also subtend 1 radian. So notice this case, yeah, 1 1 1 subtending 1 radian, here r subtending 1 radian. You can see dividing 2 pi radians by 2 pi length, you get r subtends 1 radian. So what does arc length L will subtend? So arc length L will subtend L over r radians. And that is pretty much it. So if you replace r by L, arc length L will subtend L over r radians. So there is not much to say about radians, it is just a matter of practice. So you have these theta radians, that angle theta subtended by an arc length L is L divided by r radians. So I'm just writing subtends angle because equal to is not equal to in the correct sense. It is just that the arc length subtends an angle at the center. Now let us do some examples and that will help us clear things out. So here we are going to talk about radians and degrees. So you know, if you go once around the circle, you say it is 360 degrees. And we have already seen if you go once around the circle, you also extend 2 pi radians. So 2 pi radians are equal to 360 degrees and we want to make this bridge more clear. So 1 degree is equal to 2 pi divided by 360 radians. This is 2 pi divided by 360 radians is just 1 degree. And this is equal to pi by 180, yeah. So you divide numerator and denominator by 2. So let us draw a small table linking degree and radians. So 30 degrees is pi by 180 times 30. So this is pi by 6 radians. 45 degrees pi by 180 times 45. This will give you pi divided by 4 radians. 60 degrees pi by 180 times 60. This will give you pi by 3 radians. Pi by 180 times 90. This will give you pi by 2 radians. Pi by 180 times 180. Pi radians. 270 degrees. This is 3 by 2 pi radians. And 360 degrees is just 2 pi radians as we started with.